All right, here we go. So we are doing the pre-assessment for logs. All right. All right, here we go. Number one. Again, whenever you see an E, you should think ln, but before you do that, you want to simplify the equation as much as possible. So I would subtract the 11 first. All right, it becomes e to the negative 2x is equal to 9. All right, we can't get the same base here. So whenever you cannot get the same base, you should use a log, or in this case, the ln. The ln is because you have an e right there. And so this becomes negative 2x ln e is equal to the ln of 9. I'm doing every step. The ln of e is 1. So this just becomes 1 times negative 2x is 2x is equal to the ln of 9. So you divide both sides by negative 2. And on your calculator, x is equal to, you find the ln of 9, divide that by negative 2. So the ln of 9 divided by 2 is equal to 1.098, or you could just put 1.1. Either way is fine. Okay. And this should be negative. Okay. Letter B, recognize that you can get the same base from these. So this would be 2 to the second power, x minus 1 is equal to 2 to the first power, right? Since they have the same base, we can make the exponents equal to each other. So it'll be 2, and then x minus 1 is equal to 1. And then you multiply both sides by, or distribute, add the 2. And what do you get? 2x is equal to 3. Divide by 2. X is equal to 3 over 2, or 1.5. Any questions on either of those problems? Number 2, all right, we have, here we have x plus, so we use the properties of logs, so x times x minus 3 is equal to 1. Keep in mind that on letter A, there's no log on the right side of the equal sign. So in this case right here, you have to put 10 here, right? And then put it in exponential form. So it'll be x squared. I distribute this. So x squared minus 3x is equal to 10 to the first power, right? Subtract the 10. So x squared minus 3x minus 10 is equal to 0. So remember, once you get the x squared, you're solving quadratics, what we did at the beginning of the school year last semester. All right, so you want to make it equal to 0. And then if it's not factorable, then you need to put it in the quadratic formula. But in this case, I'm hoping, I have to remember, but I'm hoping that these are all factorable. Okay, and this one happens to be factorable, because if you do this at negative 10 and negative 3, it'll be negative 5 and 3. Sorry, negative 5 and 2, my bad. So negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. So our two answers are x minus 5 and x plus 2. Make them both equal to 0. So x is equal to 5 and x is equal to negative 2. All right? You don't need to go back and check about extraneous roots or anything like that. Just right now, just focus on just getting the solutions. All right? Number 2b is a little different in the sense that you have a log on the right side of the equal sign. So in this case, you're just applying the properties of logs. And then you could just do it this way. You kind of ignore all the logs, apply the properties first, and then after that, you could, so this become, let me initially, this becomes this when you apply the properties of logs, the product property, and then because they have a log on both sides with the same base, kind of cancel them out. So this becomes x squared minus x is equal to 4x. And then again, this is a quadratic, so you subtract the 4x, you make it equal to 0. And so what? You have x squared minus 5x is equal to 0. Factor out, remember this is not the x method here, you're just factoring out the GCF. So x is equal to 0 and x is equal to 5. Right? Again, that's why we spent so much time in the beginning about quadratics, because we're in semester 2. It was maybe what, like 20 weeks ago, and we're still dealing with it. Okay. And again, it's all about you guys recognizing what to do in those situations. Like, I think you guys understand this when I'm doing it, but it's like recognizing, okay, I got to do it. I can't use the X method, but I got to do the GCS method, or so on and so forth. If it's not factorable, I got to do the quadratic formula. Right. So cool. Number 3, do you want me to go back to the last? You're good here? Everybody good? All right. Number 3 is, all right, 7 to the 2 minus x power is equal to 8 to the x power. Remember, this is a little bit on the longer side because we can't get the same base, so automatically we have to put logs on both sides. Okay. When you do that, the reason why we put logs is so that we could bring the exponent down to, so you could put this as 2 minus x log 7 is equal to x log 8. Any question on that? We use that power property in the front. All right, so so there's kind of some kind of crisscrossing a little bit. I'll put the x's on the left and I'll put the logs on the right. So I'm going to divide this side by log 7. Right, and it becomes 2 minus x is equal to x log 8 over log 7. And notice that I kind of separate the x. And then I'm gonna divide both sides by x. And so this is where your algebra really comes in handy. So this is going to be 2 minus x over x is equal to log 8 over log 7. Because these cancel out. The easiest thing to do now is just to do log 8 divided by log 7 on your calculator. So that is 1.06. So 2 minus x over x is equal to 1.0686. I'm going to multiply both sides by x. So it'll be 2 minus x is equal to 1.0686x. This is, again, algebra is really key here. You add the x to both sides here. So this becomes 2 is equal to, remember you're adding a 1x, so all you're doing is just adding 1 to this right here. So it'll be 2.0686x. Divide both sides by 2.0686. X is equal to I got 0.9668, right? Something like that. Again, if you don't get the same answer, like if we get around the same answer, we're good. Okay, so don't flip out on these. All right, we good? All right, next problem here is I'm going to add the 12. So it'll be 3 to the x power is equal to 31, right? Then log both sides. Bring this to the front. X log 3 is equal to log 31. Divide both sides by log 3. X is equal to log 31 over log 3. That equals what? Log 31 divided by log 3. And that's 3.12. Cool. We get to flow this? Everybody good? Everybody feel good about this? Yeah, the word problems, hopefully you guys are, there's only one little small difference with the word problem here, at least with the first two. So remember, it's this, I'll give you guys the formulas when you guys take the test. So no need to memorize it, just know how to use it. Okay, so A is, what we're trying to do is we're trying to find the A, or so we already have the A of 180. The R is 10%, so 0.1. The N is, it depends on whether you're doing it monthly, yearly. All right, so it's either 12 or 1, depending on, if it's monthly, it's 12. If it's yearly, it's 1. We'll talk about continuous in a little bit. And we're looking for the T. That's what we're looking for. So 180 is equal to P, which we start off with what? 40,000. And then 1 plus 0.1. Let's do it monthly. And then 12 times T. All right. So you divide both sides by 40,000. $180 divided by 40 is 4.5 is equal to, and then put 0.1 divided by 12. So 0.1 divided by 12 is 0.008. Add 1 to that. So inside will be 1.0833 to the 12t power. So what do you do here after this? What do you do after this? Yep, log both sides. Okay, can we put the phone away, please? Or your calculator? Log both sides here. Log 4.5 is equal to 12t, and then log, I skipped that step, 1.0833. I just put the 12t in front. Divide both sides by log 1.0833. So log 4.5 divided by log 1.0833. That's about 18.798 is equal to 12t. And then divide both sides by 12. T is equal to 1.566, or let's say 1.57. Cool. Oh, that sounds really low. Yeah. That's huge. Thank you. Let's do that again. So log 4.5, log 4.5 divided by log 1.00833. Thank you. So that is 181. Let me do that again. So that will be 181.31, right? Is equal to 12t. And divide that by 12. So thank you. It's more like 15 years, not Not this. Push-ups right there, you know. Cool. All right. So I think yearly we don't have to really do because you could just put a 1 underneath that, you know, and then but let's do continuous. A is equal to PERT. All right. So the amount is 180 is equal to 40,000. R is 10%. And the T is what we're looking for. So you divide this by 40,000 again. This is 4.5 is equal to E and then 0.1 T, right? Then we put the ln on both sides. Bring this to the front. And so it will be ln of 4.5 is equal to 0.1 T because this is 1. Divide this by 0.1. So ln of 4.5 is equal to 1.5. Divide this by 0.1. You'll get 15 as well. So T is equal to 15. By the way, whether you compound it monthly, continuously, yearly, it should be around the same answer. Okay, like all those answers, if you get like 15,000, you should get around 15,000. Okay, they're going to be slightly different, but the compounding doesn't really matter that much. Okay, it might be off like $100, $200, but it's not going to be like you can't get like 15,000 and then like 100,000. Like it shouldn't be that much of a difference. Okay, when you guys compound it different ways. Cool. Letter B is the bacteria. We didn't go over this problem, but if you guys see the formula right there, it's very similar to what we're doing. So find the formula for the number of bacteria at time t. So this would be the formula right here. The P of t is equal to the P of 0, 2, and then T over the number of minutes, or I guess the rate of every, see how it says it doubles every 20 minutes? I guess you could put the rate right here. So the P of T, so the letter A to answer that, what's the formula? It'd be 16,000. 2 times T to the T over 20 power. I remember last year, and I warned you guys this year too, I can't tell you how many people multiplied these two right away. 16,000 times 2. I remember half the class did that. Do not do that. Because why? The 2 belongs with the exponent first. This 16,000 is the quantity of itself. Okay, so do not multiply the 16,000 and 2. Do the exponent first, and then multiply it by 16,000. All right, so that letter A is this right here. Is find the formula. This is the formula right here. Find the number of bacteria after 1 hour. So P of T is equal to 16,000, right? Times 2, 1 hour would be 60 over 20. So the P of T is equal to 16,000. And then it'd be 2 to the 3rd power, right? What's 2 to the 3rd power? 8. 8 times 16,000 is what? 128,000. So P of T is equal to 128,000. Okay, but just notice that I did the order of operations first. I did this first, and then I multiplied by 16,000. Now let's go backwards here. we want to see how many minutes it will take to get to 200,000. So this is where we use logs. Right? So now the first step is don't multiply the 16 into 2. You divide by 16,000 first. $200,000 divided by 16,000 is equal to 12.5 to the t over 20 power. Then what do? Log both sides. The log of 12.5 is equal to, and then we'll put the t over 20, log 2. Divide both sides by log 2. So log 12.5, sorry, log 12.5 divided by log 2 is equal to 3.643. And then multiply both sides by 20. I'm skipping over the algebra part because I'm hoping that you guys kind of get that down, but a lot of people get these wrong, just the algebra portion. So, all right, so t is equal to 72.87. So it'll take about 73 minutes for it to get to 200,000. Cool. All right, almost there, guys, almost there. All right. Graph the following. All right. I think we went over this the other day, but just so you know, it should look something like this, where you have a y equals x line, and it's going to look something like this. All right, so that's the original. You probably should put a table together. We went over that yesterday. All right. And then if you add 2, remember it's in the outside, so if you just do something like this, that would be fine. And just put plus 2. Something like that. But I should put different colors. Okay. I would like a table for this one. Okay. All right. For number 6, the ln of 6x plus minus 5 is equal to 3. Remember, the ln is equal to log base e. 6x minus 5 is equal to 3. Put this in exponential form, it will be 6x minus 5 is equal to e to the 3rd power. So e to the 3rd power is equal to 20.08. Add 5. It would be 25.08 is equal to 6x, and divide by 6. So x is equal to 4.18-ish. Round to the nearest hundredth. Okay, put everything. All right, letter B kind of goes into our next lesson. That's the splitting up of logs here. All right, so let's go here where find the log of 14 over 3. All right, so notice that if you go 14, right, it's log 2 plus log 7. Right, because 2 times 7 is 14. That makes sense? All right. And then it's minus what? Log 3. Right, because you're dividing. So you're so you find factors of 14, which are 2 and 7, right? So log 2 plus log 7, 2 times 7 is 14, minus log 3 because that's division. All right. Now what's log 2 equal to? X, right? What's log 7 equal to? Z. What's log 3 equal to? So this is your final answer. It'll just be X plus Z plus, sorry, X plus Z minus 1. All right. Any questions on any of those? Thanks for hanging in there with me. It was a lot, well, a little bit longer than I expected.